Okay. Let me just try to move this part here. I'm not seeing the chat, so if anyone has a question, Arjun, please read it to me and I'll continue the conversation from there.
Yes, sure.
And yeah, go ahead, Arjun.
Yes, sure, I will share with you.
Yeah, thank you. And once again, thank you so much, guys, for coming. There are a lot of people that are very interested in TCA and composable architecture, which makes me very happy. And I'm very pleased to be a part of this workshop and to present to you some features of the composable architecture. So let's get started. And first of all, where are you guys from? Can you reply in the comments with the flag of your country? I'm not sure if you know, but I'm from Portugal. India, yeah. Home of the yoga. That's awesome, guys. Thank you so much. Awesome. Let's get a little bit about me. I'm an iOS developer. I write weekly on my blog, codingwithvera.com. And fun fact, I started my career in the QA field. I was a QA analyst first, but then I changed to iOS development. Mobile development gets me really excited, and that's why I changed. So let's see the agenda for today. I'm going to set some ground rules. It's not, I'm not the police, I'm not enforcing rules, just for you guys to know how I usually do presentations and get more comfortable with it. And I will present to you the goal of this workshop, and then I will give a brief introduction of TCA. We're going to solve a problem using TCA, and then we'll have a workshop, and finally some Q&A. So first of all, the ground rules. I want you to imagine that during this workshop, you're walking through a staircase with me. And in each slide, I'm going to present something, a very small increment of TCA or a brief notion about the composable architecture. And you'll feel like you're climbing a very small steps in this staircase. But it's very important then that when you don't understand something, you let me know. You can raise your hand in the meeting to ask a question, and there are no stupid questions, so ask away. If you don't understand anything, you can click on the raise your hand in the Zoom. You can ask Arjun. You should feel comfortable doing that. And I want to make things more interactive, so I'll maybe ask your guys' opinion on this. And if you're not comfortable speaking, let me know. There's no problem. And most importantly, it's Saturday, guys, so let's have fun. This is a very informal presentation. It's just to get our feet in TCA, just getting started. So let's see the goals. First, we're going to learn the basics of implementing a view using Composable Architecture and SwiftUI. Fun fact, Composable Architecture doesn't need SwiftUI, you can use UIKit. But for the goal of this workshop, we're going to work with SwiftUI. You only need to know the basics of Swift and a little bit of SwiftUI because some of the views will use that. And you'll know different types of concepts like state, action, reducer, store. You will also understand how different components interact with each other. And finally, the advantages and disadvantages of using TCA. So my experience with TCA. All of the projects that I've worked on in my current company use composable architecture. I implement composable architecture in my personal projects, especially as an architectural pattern for the UI component. And I actively follow Point Free videos. And if you guys don't know, Point Free is the company that created composable architecture. So when I talk Point Free, just know it's the company that created it. And why should you trust me? Why am I talking to you guys about this? Why should I be a source of truth in this case? Well, You shouldn't trust me. The main goal of this workshop is to learn from each other, and you should create your own opinion on this topic. And maybe, who knows, at the end of the workshop, you'll say, I don't like TCA at all. And that's perfectly fine. And you should also ask questions and keep making your own opinion about this. So finally, let's get started on the composable architecture. Like I said, composable architecture was created by Point3, the company that created it. The authors of composable architecture are Brandon Williams and Stephen Sellis, the guys that you see here. And there are a lot of videos and in-depth tutorials that are available on the Point3 website. If you search point3.co, you'll see a vast collection on different topics like unit tests, integration, SwiftUI, and they also have a Slack channel that I recommend you join. You can get an invitation through their website, and also Point3 sometimes releases free videos, but most of the videos are through a subscription-based payment. So, what are the main pillars of composable architecture? First is state management, then composition. Sorry, go ahead. Did someone say anything? Okay, I'm going to go ahead, but if you guys have any trouble, let me know. So first is state management, like I said. Next is composition, side effects, testing, and then ergonomics. I'm going to explain all of these components. So first, state management. What is state management? Is basically I'm using simple value types and I'm going to share state across many screens. What does this mean? When you have multiple screens, like you have a name for a user, this can be considered a shared state. And imagine that the name of the user, like Vera, is in across a lot of screens and can be changed. And this shared state, this name, should be immediately changed, and this change should be seen across many screens. This should be immediate. This notion of shared state is like everyone knows this component, and everyone is looking at the same component, and when it changes, everyone receives the notification. And about testing, I'm going to show you guys how to implement tests, but testing is very easy to implement. You'll see. And it's very simple to write integration tests for features with many components. And composition, like the name Composable Architecture, is to break down large features into very small components. These components should be isolated, and this means that the component can live and can be used by itself. And all of these different smaller components can be glued together to form the large feature or the large component. About ergonomics. So ergonomics basically is what Point3 wants to come across with this ergonomics statement is you should do this, you should accomplish all of the above with as few concepts and moving parts as possible. So it should be very easy to do what I just said. You don't need a lot of boilerplate, a lot of code to set up this. So let's see the basic usage. This part is are coming a bit late, Siddharth? Okay. Arjun, are you also getting a delay on your side?
No, I think maybe he has an internet issue because it's working for me. And
Yep.
I think Ratnesh raised the hand.
Yeah, go ahead.
In previous slide, you mentioned shared state. So is it the feature that shared property wrapper or a different thing?
It's really the macro shared state. It's a shared property. You can think like that, Ratnesh. So yeah, if you think about how Swift handles macros and this part of SwiftUI, shared state is just that, just with an extra component over it of the TCA part. Did I answer your?
the shared state feature is introduced in 1.10. So is it, are you talking about that feature or it is just a state management feature?
It is the idea of shared state. Yeah, it started on 1.10, but shared state as a notion, it's before that. So I just want, from this, I just want you two guys to know, I have some state that can be used in a lot of screens, and when it changes, it immediately can change, and it will reflect on a lot of screens. That was my main idea. I hope I answered your question, Ratnesh.
Yes, thanks.
Okay, awesome. If you guys have any other questions, let me know. So let's dive into the basic usage. So when you're building a feature, let's get the main components, the main definitions of the components, which is state. So state, basically, it's the data that your feature needs to perform the logic and render the UI. That's it. When you think of state, you should think data. The actions are the actions or user interactions that you need on the feature, notifications that you receive, some type of action that happens in the UI. And the reducer, I'm going to say a lot of reducers. This is basically the handler that takes the state, takes the actions, and handles the state and returns effects. Effects are basically another type. You can think of an action, but it's a little bit more complex than that. But think of it as a component that handles actions and state and returns effects, side effects. And store. The store, you'll also see this in the code. It's the runtime that actually drives your feature. The actions are sent through the store, and you usually declare the store in the UI. The store runs the reducer and its effects, and you observe changes in the UI through the store. So if you think about all of these components, store is the big boss that handles everything. So let's see a few code examples to get for you guys to get accustomed. So how can you define state? Like I said, it's the data that your feature needs to perform the logic and render the UI. So it's just a struct, a value type that, for example, this is a list of fruits, but it can be, in your case, a name, like I said, whatever, just the data that your feature needs. And it's defined as a struct. How to add an action? Like I said, actions are that happen in the UI, like user actions, notifications, are defined as an enum, and all of the cases that you think your UI needs or you set as user actions, notifications, will be declared here as cases. And how can you create the reducer? Basically, and let me just get the pointer now. So the reducer handles all of the actions and state, like I said, and returns effects. Is declared in the body, so you really declare a var body that is of some reducer of self, and then you reduce. You need to add this line that delivers a state and an action, and you take all of the actions that you declared before. Let me just remove this again. So you take all of the actions that you declared here, and you add all of the cases to that. And sometimes you need to send. Do you guys remember the returns effect? So you send something. It might be another event, another action that another component will be observing, or you can just return none. But one major thing about the reducer and this switch, sorry, about this switch is you always need to return something in each case. So you guys need to know that. So iterates all the actions and replies with effects. Is everything looking good? Yeah, Ratnesh, go ahead.
In previous slide, you have a case for view.button tab. So is that user action a differentiator?
Yeah. So I'm going to explain a little bit, and nice catch, Ratnesh. Ratnesh is basically I would define this as a, for example, imagine that I have the actions for this one. So I would go here in action, right? And then I would create another case for view. And inside of it, I would have case, what is the name? Button tapped. But you will see this after. But basically, why is this like in this case? It's perfectly fine for you to declare all of the cases in the enum action, but point 3, and if you guys watch some of the tutorials, they suggest that you split each actions in an enumerate to separate. So for example, every action that is happening in the UI, you declare it as a view. So you would have enum action and enum view. If you want to send an effect for another component, you would create another enum inside of here with the enum called delegate. But I will talk about this further. But thank you so much for asking, and I hope I answered your question.
Sure. So like there can be 3 kinds of actions: user performing, system, and the notification delegate.
Yeah, delegate, or you can create your own. Really, you can create your own logic, your own ideas, but because you can have enumerate, not no pun intended, but you can have enumerate enums inside of the action. But I want you guys to know that from point 3, they say when it's UI, it's enum view. When it's something to another component, you want to delegate the task, let's say, it's another enumerate delegate, but this is not mandatory. That's basically the gist of it. But thank you so much for asking. So, like you can see here, the famous delegate, the view, but let's see it further. Let's see an example of a reducer. This was the reducer that produced this body Ratnesh, right, by the way. So as you can see here, like I said, I have an enumerate delegate that I'm going to send to some other component. And I have the view action because this is an interaction of the UI. And I need to declare each case here. So that's why it comes across like this. .view .button tapped, because you need to connect the action with these other enumerates. Does it make sense for you guys? Let me know in the comments. And I also have the emojis, so let me know if you guys are understanding everything. Does it make sense? If you guys don't understand, we're going back and talk about it. We have plenty of time. Awesome. So we have an example of a reducer, like you can see here, structure, fruit card reducer, and on this reducer, you need to declare all of the state, action, and the reduce function. In this case, this state, since it was literally the fruit state, if you want to connect both, Adolf, do you want to ask anything?
No, sir.
Okay, no problem. You need to declare a type alias for the state. That's it. This is just another way to declare what we saw before. So let's get it moving. Let's see how to create a store. Like I told you guys, the store, you declare it in the UI. So for example, I have a fruit card view. You need to declare the store, and it needs to be a type of store of from your reducer, because like I said, the store is the runtime of everything that you created before. And on the body of your view, before you would just declarate a Z stack and move on, you need to before create a view store. And you have something here. What is this observe? This observe basically just adds the state that you want to observe. I want to observe everything from this code before. I want to have access to everything. So I declare it as 0. But if you only need like the view actions, which makes sense because you only need to use the view actions, you'd need to add a case path, like case path dot view action, for example. That's it. Sorry, you need to scope the state. I said action, but it's the state, sorry. If you had a lot of state here and you only needed a part of it, you can scope it here. The point three, the guys from point three said that it's not a very good practice to always add a $0 because you only need to observe the state that you want. So be careful when adding this, but in the simpler cases, you don't need to worry, just add this. And then this produces a view store. And with this view store, you will connect the actions that you created before. So view store.send, view button tap. So when I click on the start button view or just a normal button, I'll send this action. And everything now is connected and working. So this is the main, very simple approach to the components. And I'm going to move forward to an example. Can I move forward? You guys understood everything? It's going to be an exercise next, so be prepared. Okay. Awesome. So let's see an example. I'm going to create a new feature, guys. I'm the product owner. I want you developers to create this list. This is a list of fruits that I have. Each element is of type fruit with an image, a description, a title, and it has a small button like the star button that we saw before. And when you click on an element, you should show a detailed view of the fruit. This is my feature as a product owner, and you guys want to create this using TCA. So I want you guys to do an exercise with me. I want you guys to, by yourselves, define the state of this feature and the actions that you would need to do. So the state is the data that your feature needs, and the actions are the actions that happen in the UI. You have 1 minute, and I'm going to show you again the components. So what is the state in this case? And what will be the action? Arjun, can you set the timer for 1 minute? And this video keeps looping, so yeah, so the states and the actions. Actions that can happen in the UI and the data that your feature needs to perform the logic and render the UI. Let me know, Arjun, when the timer is up.
Okay, sure. It's up.
Okay, awesome. So what solution did you guys come up with? Does anyone want to have a discussion and show their solution? Can I pick someone from the crowd? Everyone is very shy today. Okay, I'm going to pick, okay. Your fruit info like image, name, and description, while action can be show details. Okay, that's the solution. Awesome. Thank you, Akshay. Sorry again if I mispronounced. Does anyone want to come forward with their solution as well? Come on, guys. The worst it can happen is it's different from mine. That's totally okay. Satya, very, very good addition. We also need to include the swipe. That's very interesting. But in SwiftUI, when you have a horizontal list, you already can handle the swipe when you have a list. So great idea. But in this case, fortunately, it's not necessary. I've presented alert. TALSP, sorry if I mispronounce again, but this is another good idea. State of presented alert. Can you explain a little bit? If you want to come forward, if you want to talk on the mic. Presented alert, I'm not sure if I get what you mean. Oops, sorry, my solution. And another action for getting back to the scroll view from the detail view, that's okay. That's a great idea. So I'm going to show you guys, and I'm very happy for you guys to comment. I'm going to show you my solution, but it's just another solution. It's perfectly... When the action button press happens, the reducer creates a new state, which shows the detail, yeah. But, okay, I get what you mean, the state of the other screen. When you click on the start, you already have the component, the state for the fruit you want to present, right? So you don't, I'm going to show you guys, but I understand what you mean. I'm going to show you my solution, but it's just another solution. Clearly you guys have a different solution than mine, and that's perfectly fine. So I'm going to explain you guys my solution. As a product owner, I wanted a list of fruits. So I need to create 2 reducers. I'm going to create one reducer which handles the list. Let me just get here. This list, like Satya said, you don't need to handle the swipe. This is handled automatically. And you'll, for me, the first reducer would be like fruit list reducer. And what is the state of this fruit list? Is a list of fruits. That's it. And what would be the other reducer, guys? The other reducer would be fruit to show each card, right? This one, this one. So for each element, there is a fruit reducer. And for the actions, you guys said, and I totally agree, one of the actions should be go back. I didn't add that one, but the most important one that I want you guys to see here is the button tapped, this start. Some people said show details. I added a fruit button tapped, but you guys are totally correct on your solutions as well. So let's move forward. But something here is different, right? It's .fruit.button tapped. Why is that? So I'm going to explain you guys another front, another part of TCA, which is integrating multiple screens. So as you can see here, this is a list, a reducer list that has tiny components, not tiny, but smaller components of just an element, the fruit reducer, like I said. So I'm going to show you a brief diagram, but I am going to show the code after. So as you can see here, my fruit list, like I told you guys, receives a list of fruits. And this list of fruits will populate the fruit cards, each fruit card. So I receive strawberry. I'm going to have a view here that is going to show strawberry. And each fruit card will have an action that says I was clicked. But the fruit list won't hold on to this action. He doesn't care. He's not the one that should be handling the clicked, right? So he's just going to be observing the fruits and be observing and waiting when someone is clicked. This observation is it's not new, of course, it's not new from TCA, it's the observable pattern. So this is basically the idea. So let's see how could a fruit reducer be implemented. This is just an idea. So like I said, I would have a list of fruits with the fruit state would be the title, like you guys said, the description, the image, the colors, whatever. It will hold on to a list and the actions. I don't need, the list doesn't need to have actions. It could have the swipe, like some of you guys told me, but we don't need it because the list already handles that part. The list itself doesn't hold on to any actions, but is interested in knowing when another child component is clicked. So I'm adding a case here of type fruit. This is just a naming with the action of the fruit card reducer actions. But I haven't shown you the fruit card reducer yet. But this is another part. This is a powerful implementation of enumerates. You can have arguments inside, and this is paramount. You can see in the tutorials from point 3 that when you want to know, when you want to observe actions from your children, you add a case with a naming that you want, and then you add as an argument the actions of your child, so you can connect everything. And on the reducer body, like I showed you before, on the switch, you need to iterate on the actions that you have. So when the case.fruit.button tab happens, I'm going to do something here. For example, I'm going to show another screen. I changed some state in this case. Sorry, Siddharth, you don't agree with me? NTD, I'm not sure what that means. Let me know, because this is a part. Okay, Siddharth, no problem. We have the talk recorded, so you can watch it after. No problem. So in this part, the case, the child, for the action button tapped, because I want to say specifically, I want to hear for the button tapped, I'm going to return none. I could return an effect or not, but something important that needs to happen here is when you create a case for one specific situation, you need to add the rest of the cases after. This adds a lot of extra code. Yeah, Ratnesh, go ahead.
So when we are observing the fruit card reducer action, so should we also have the fruit card reducer state in the fruit list reducer?
You can have it. It happens sometimes. For example, you can have the fruit or another element, but you wouldn't have state here in this case. You would have in the state.
Yeah, in the states, we should also have the array of fruit card reducer states.
In this case, you don't need it because you already have it in the list.
Okay.
So by iterating the for each in the store, you get the fruit state. But great question, Ratnesh, because you already have that, but it's hidden, right? Because I'm holding to fruit card reducer state here. Okay. It's in the form of a list. Great question. So fruit card. So what does the fruit card do? I already told you guys. So it holds a fruit as its state. So this is a very simple diagram, and it holds just one action, which is I was tapped. That's it. I'm going with the store, send the action when it's clicked, like you guys saw in the code examples. And when this action is sent, I can send a delegate, like I showed you. I can, in this case, a parent can be listening on the button tab, like it's in the case here, and the store will send an action when the button is clicked. So let's check the fruit card reducer. This is not new. You guys saw this part in the previous code. So fruit state, Ratnesh, it's the state that we talked about, but just one element. and the enum action with the view action, delegates, and I have a delegate for the button tap, and I will send it as an effect here through the body of the reducer. So this is the main gist of integrating multiple screens. Did you guys understand this component? Do you have any questions? This is a very difficult part, so if you guys have any questions, it wasn't clear. Santosh, thank you so much for asking. What is the first purpose of having a delegate and a button action? Honestly, you can have just one. Like I said, this is just for readability purposes. You have view action and delegate in this case because it's a good practice, a good code practice from point 3 to split everything. So you should have the view actions in a enum, and you should have delegates in another. So when I'm sending something to the parent, I'll send it through the delegate. If it's happening something in the UI, I can have this. But this is totally optional, totally. You can have just a case button tapped and you send it here. The problem is when you have an action that does a lot of things, if this escalates to a bigger code, how can you detect bugs? And how can you test this in a modular or unitary form? It becomes difficult. Did you understand? Do you agree with this statement? Yeah, Karen, it's just for separating logic. But you guys can be totally rogue, just one case for everything. But it will be harder down the line. That's it. Thank you so much for asking. So, like I said, just another diagram in another UI component that does the same thing. So I was clicked, the button was tapped, and the parent will be observing. So let's talk, since we started on testability, let's talk unit tests. So how can you implement unit tests? Your subject under test will be of type test store. So you guys remember when I showed you store in the UI, you created a store of your reducer. You should be on the lookout. So when you implement unit tests, you need to create a test store with the relevant initial state, because a test store needs a reducer, and the reducer, the constructor of the reducer, can have an initial state. And you call it. So how do unit tests in composable architecture work? You basically test based on actions that you send through the store. So you guys remember on the UI, I clicked a button. So in the unit test, you would say store.send button tapped. And this part of sending and receiving, so you can also send actions, but you also can say store.receive, and you can receive some actions. The observe, for example, I'm a parent and I want to observe that this action was called. And during the receives and the sends of the store, you can check the state. Since they are value types, this is a major advantage of TCA. In these actions, you can assert the elements of the state, and you can also check. You can do unit tests like that. So basically, it's a little bit different from what you guys are used to, but it's very easy. For example, to test interactions with the user. For example, I'm going to give you guys an example in UIKit. Pull to refresh. It's very hard. You need to create a lot of boilerplate in UIKit to create unit tests for that. And some companies don't create it, they just create a UI test because it's easier. But in the case of TCA, what would you do? In pull to refresh, you would probably need an action that the store stands, like pull to refresh tapped. And in the unit tests, you just need to simulate that action. That's it. this is very, so let's see an example. For example, here, I create the system under test, the element that I want to test. So the test store, like I said, test store can have an initial state that can be empty or not, and has a list of fruits, but I could not have added it, and I call the reducer, onboarding reducer, fruit card reducer, wherever. So this is the main part. In this case, and similar to the list, to the children sending events and the parent listening. So this test, what was the main goal of this test? So when a fruit card is tapped, I, as a parent, should receive a notification. So I'm not going to create the child component and attach it to my parent. It doesn't work like that in TCA. But I can simulate an action of my child like this, because I have access to the children actions. So I'm going to call suit.send.fruit, state fruits first, whatever, just to pick one, and say that the view button tapped was clicked. But this is pure simulation. This is not, and it's very nice because, as you know, when you create a unit test, you want the outside components to be mocked. You don't want to use the real ones. So after I simulate the button tapped, I receive, so when you send, usually, for example, I could open here and see the state, but usually when you send, you should be on the lookout for a suit.received, but it really depends on the situation. So in the received, on this action, or for example, the delegate, I can assert the state of was fruit tapped, or I could assert the state of another thing. You can assert your state here. So this is the main logic of the tests, but I highly recommend you guys to go to Point Free GitHub, and they have a lot of examples. For example, they have complex apps, smaller apps with a lot of tests, integration tests, that you guys can see different cases. So can I move forward? Did you guys understand this part? Is it okay? Let me know if you guys have any questions. There are no stupid questions today. Actually, very good question. I don't need to worry about integration. In unit tests, you want to test in a unit in a very tiny, not tiny, but the smallest way possible, right? Yeah, sure. I just wanted you guys to know that you can use this logic, the send and receive, to create integration tests. That's it. In no way, shape, or form, I want you guys to mix things. You can have integration tests, you can have unit tests, that's it. But thank you so much for asking. And let's move forward now. Let's do the workshop. Are you guys excited? This is the hands-on part. So I'm going to show you guys what we are going to build today. We're going to build a to-do app. And I decreased the amount of things that we're going to do just to, I don't want this to carry over too much. So basically this is a code along, so you guys can start opening Xcode if you want to follow along. And I'm going to teach you guys about how to add TCA to our project, to any project, and we're going to create a simple to-do list. So I'm going to create three features: the adding to-do, like you can see here, the adding a to-do, clear the completed, and deletes any element of the list. So when I click on the check mark, as you can see here, it marks as completed. The add creates a new element in the list, and the delete is just a standard swipe. There are very little SwiftUI in here. I didn't want you guys to have a lot of boilerplate and setup code to start. So are you guys ready? If you guys want to follow along. I'm going to go really slowly if you guys want, but that's perfectly fine. You just want to check it out. So I'm going to start then. Before we start implementing code, let's do the exercise we did before. How many components do you think there are in this feature, the to-do? Does anyone want to give their idea? How many components would you create? Or how would you handle this in TCA? Can I pick someone from the crowd if no one talks? You guys are not afraid of me, right? I'm a little bit scared. So, Parth Patel, I'm not sure if I'm mispronouncing your name, but do you
Yeah.
want to give your idea?
Yeah, I have a idea about this. I think so. Yesterday I checked similar example on the composable architecture on GitHub. So
Yeah.
I have exact answer of this. I think so. State and actions, the two components we need to create in the reducer, and the body part can define that large part of the handling, and we can add that button actions a mark as a completed, and typing and completed to-do list and to-do list.
That's awesome. Thank you so much, Parth. And yeah, totally agree with you. This is, I wanted you guys to do a very clear example. So yeah, the to-do list, I agree with you, Parth. It has two components. One of them would be the to-do, just one row, one tiny bit, one part just. And what does it have? It has a text field. Since we write on it, it needs to be a text field, but just writing on text. And you would need to have a check mark to mark as completed. This would be one component. And another one would be the to-do list. So what does the to-do list do? It adds the to-do. It handles all of the list of to-dos that you will need. It will clear the completed. It will delete from the list. So very, very similar to what we had before on the fruits. You will have a list of fruits. In here, you will have a list of to-dos. So are you guys ready? Can I open Xcode? Come on, guys. Don't be afraid. This is going to be a very simple example. So if you guys want to follow along, great. I'm going to do it slowly. But if not, that's totally fine. So what I'm doing is I have this set up before, but basically I just created a new project, a SwiftUI project, and then on the to-do project workshop,
Hi, this is Kushal.
Kushal, yes, sorry.
So actually, this architecture is a bit new for me. So I have worked with MVVM and MVP. So ask what is the beneficial with this TCA instead of that MVP or MVVM? Maybe you explained earlier, but I joined late, so I would like to
No
ask.
problem. No problem, Kushal, and thank you so much for asking. That's a very, very pertinent question that I haven't talked about yet, but I'm going to talk about after this workshop.
Okay.
But basically, I want you to know that a to-do, guys, if you guys needed to do this on a very big project, let's see, you maybe don't need to add TCA on this. This is just another tool that you guys want to know. And Kushal, you come from MVP, MVC. MVC probably is easier to implement this. It has less boiler code, but it has but TCA, what I want you guys to know is that TCA has a lot of powerful superpowers to when you have a lot of screens and you have a lot of integration and this shared state. This is done immediately. So think about it as you can maybe add TCA if the feature is very large. It depends on a lot of components. But like you said, Kushal, and sorry if I mispronounce your name, but maybe on a Todo app, maybe I'm going to add MVC in real life. That's perfectly fine. It's just another tool.
Yeah, mostly people use MVVM and MVP. So I usually work with MVVM, that model view model. Generally, people use that. But I also read somewhere that MVVM is not appropriate for SwiftUI project.
Yeah, that's true. MVVM is very different, but MVC is still in fashion. It still works.
Those are the Stone Ages, I guess. People
Yeah.
use.
So it really depends, guys. You don't need to now. I don't want you to guys to live here and do TCA in everything that you see. So it's just another tool. But thank you so much for asking, Kushal. No problem if you arrive late. It's totally okay. So as I told you guys, let's move forward a little bit on the workshop. So I just created a SwiftUI project, and in here I added the package dependencies. And by adding package dependencies during SPM, I already use Composable Architecture, so it shows up here. But in case of you guys, you just pick this, you just take this link that I sent in the chat, or you can just search it. You just say Composable Architecture GitHub and it appears, and you add it in the package URL and it will appear here. You click on add package. I already have that, and the package dependencies will appear here. So this will take some time. I'm going to move forward a little bit, but don't worry. This is I will be as simple as possible. So let's start with the smallest component that we have here, which is let's go back to the keynote. The smallest component that I have here is the element in the list, the to-do, the first component here. So let's create it right here in the content view. Let's do it. So I'm going to add now just the basic body. So instead of this, I'm going to remove this. So I'm going to add an H stack. Oops, this is kind of slow. I'm going to add an H stack with the button, this check mark that you guys see. This is just a button because there is an interaction here. And this has I don't need to have this first. I just need to have button label, this one. This label would be the image that I told you guys about, the little square, just a standard image from the system images. So system name, check mark, dot square, or square if it's not completed. But this needs to have, this will be a binary. This will depend on the is completed or not. I'm not going to do state here right now. I'm just going to add the UI. So let's just square. Just check mark square first, and then we'll do that later. So I'm adding a button style. I know the purpose of this workshop is not SwiftUI, but if you guys have any trouble understanding, let me know. And you will have the text field, like I told you, text field. So place your to-do here or something, just title. And I don't have any, let me just add the text. For the text, you need a binding of a string. So binding is not a new concept for the composable architecture. It's a concept that already existed in the UI. And I want you guys to understand. I'm not sure if you ever heard of it, but I brought official SwiftUI documentation. So the notion of binding is basically a property wrapper type that can read and write a value owned by a source of truth. So basically, when you have text fields that change and read, in this case, and write, because I'm writing on it, you need to bind the value to something. In this case, we need to bind it to a string. But I don't have any place to place the text that the user is placing here. So maybe I'm going to leave this as it is now, for now, just going to finish up the SwiftUI. And after that, I'm just adding a foreground, probably I don't need the foreground color now. So I finished the SwiftUI. It's not working because I need to bind the component here, but we can move forward to the reducer, right? So from TCA, the latest version of TCA changed a bit. So basically, when you add the reducer, you need to create a macro, not create, but you need to call the macro reducer. So after this, you can create your structure, struct, to do reducer. And after this, we have the reducer. But you need to have state, right? And what would be the state of a to-do? What do you guys think? Does anyone want to come forward? To do, name and status. Karan, that's it. Great. Thank you so much for writing. Yeah, that's it, the description. Name, text, description, and status. And what would be the status? ID, name, and status. Good guess, ID. But in this case, I'm not going to add ID now. We're going to need ID, but let's add just for now the name and status, okay? I'll talk to you guys about the ID after. So something like name. I'm going to add name since you guys added this. So this is a var that will start as empty, and we'll have is completed. This status that you guys talked about is completed of type Boolean, and I'm going to set it as false first.
This should be in state struct.
Is completed status, yeah, sure.
This should be in state structure.
Yeah, sure, Atnesh. Yeah, sorry, I was going too fast. Yeah, thank you. So struct state. Oops. I'm going to add this, and that's it on the state, right? So what would be the action for the to-do? Do you guys want to say something? Want to guess?
Button tab first check mark.
Button tab, Satya. Good. I think I was thinking the same thing, but in this case, so you're saying when I tapped on the check mark, I'm going to do something. I'm going to change it. The thing is, for now, we don't really need to. We're not going to do anything with the status, right? We're just going to, for example, in this case, in this case, I'm just going to check mark it in the UI. Mark checked, yeah, Shintan, yeah. The strike through, that's right. But we can go that route, but I want you guys to know that the strike and the mark, the check mark, is not a state change, right? I'm going to change the is completed, okay? But these are UI changes, pure cosmetic changes. I'm not going to show a button, that's it. So in this case, even though I agree with you guys, it would be simpler to not have any actions. And when I click on the check mark, I can just have this, for example, the system name check mark based on the state that I have. That's it. So basically, as an element, let me just check. Yeah. Since I can change, I'm going to show you guys, but basically there is a simpler way to use this in SwiftUI. But if you wanted to mark as checked as an action, you could. That's totally fine. So let me just create the actions and I'm going to show you what I mean. So enum action. So the enum action for this time and at this moment, it may not be obvious, but you will need to bind it to the to-dos, to the list that is calling this element. So when in TCA, when a child element needs, for example, in this case, I want, for example, to clear elements, to make some alterations from the parent point of view, the child needs to be conformed to bindable action. So in TCA, when you want to do these types of bindings, and also we use binding here in the content view, we need to have bindable action here. So let's see let me see if I can check. So an action type that exposes binding case that holds a binding action. So what is a binding action? Let me just maybe build the documentation. And when you add bindable, you need to have obligatory, it's mandatory to have a case of binding. Binding like this. Binding action.
Sorry, could you repeat? Here the child is a text field and parent is a list. Are we binding?
Yeah.
Child. Okay. Are we okay, please go ahead.
Sorry, Kushal. Finish your question, please.
I'm not able to understand here that we are binding between child and parent. So here child is a text field and parent is a list view.
Yes.
So how we are binding between text field and list using bindable action, is it?
Yeah. That's a great question, Kushal. So basically, I'm going to do it a little bit later if we have time.
Sure.
But you will see that when I create the list, I'm going to call a binding reducer. This is the glue that makes everything come together, right? So maybe I'm adding the binding here, and like you said, where am I connecting everything? When I create the to-do list, I will call the binding reducer with my actions, and you will see this connection after. Okay. I'm not sure if I made myself understood. So basically, I'm just preparing the binding now as a child.
Okay, it will be understandable. This is understandable. Okay.
Okay, awesome. Thank you so much, Kushal. I'm going to move forward a little bit, but just for you guys to know, this binding is because the parent needs to bind to the child. So as of now, we don't, you wouldn't really need it to have this. So I will have the body is, sorry. So some reducer, state and action that I already declared. And like I said, I need to glue everything together. And I don't have any actions, but I have the bindable action. So when you have bindables, you obligate, it's mandatory to call first bindable action. So you need to do this. And since we don't have any, sorry, not bindable action, binding reducer. So in this case, you have bindable actions. The state will also be bindable, as you will see here, and the reducer will be binding reducer. And since we don't have any more cases here, I don't need to add anything else in the reducer. The reducer could be empty. But if we had another cases here, the binding reducer needs to be first. And after that, you would have reduce and so forth, so forth. Let me just okay. So I already have this part at the build phase, that's okay. So I'm going to change a little bit of the content view and add the state, the store that we need. So as we saw here, the text field needs a binding. And before I showed you guys that usually we add the view store here. But do we need the view store and add another bracket and make the code even more to the right? Not necessarily in this case. Since we only need to bind the store to this text field, and the button will check for the is completed by toggling it, I just need to add here a bindable, again, bindable, store, that is type of store of. Same thing as I showed you guys before, just this is simpler than just create a view store. You don't really have a view store in this case. You just have some elements of the store that will be observed and changed. So to the reducer in this case, and here. So the text field, where is the name that I need? It's on the store. It's on the store.name, right? But this is a binding. And binding, you usually don't just place here store.description. You need to add the $sign. So when you need the binding of something, you need to click .name. In this case, store.name. So in this case here, let me just check. So this is another problem. Basically, referencing a subscript, the bindable, requires that the state must be observable. So this is not this part is just a normal change. So this needs to be of type observable state. This would need to change to be bindable. So I need to add this macro here. So now this part, there is no problem. But I want to ask you guys, I still can't toggle the is completed. You guys told me, and you told me correctly, if I have the action for completed, I would need to add it here. But I'm making things more simpler and I don't have any actions here, but I need to somehow toggle it in between two states, right? So in this action, I'm going to open this here. So when I click on the button, what do I need to do? Star dot is completed dot toggle. That's it. Don't you guys find it simpler? then store.send action, and then the action here, you can just say toggle back and forth. And this will directly change the state of is completed. That's it. So there's still one change that, so now we're toggling the state, which is fine. But now we have another problem, which is this, in terms of UI, is not doing anything, right? So basically, what I need to do is, when this is toggled, I need to switch back and forth the system name image. So let's do that. So basically, I'm going to do a for here, store dot is completed. If it's completed, I'm going to add a check mark. If not, I'm going to add a square. And that's it in terms of UI. So, but now, as you can see here, the preview doesn't work because the content view needs a store, right? Because I told that one of the parameters that is needed here, one of the elements, is store. So I need to declare it here. So let's see. For when you call the view, you need to do this. You need to create a store, and store has an initializer. You remember when I talked to you guys about unit test, the initial state that you can add on the test store? It's the same thing here. So you have initial state, and I can place the state here. So I'm going to do another to-do reducer dot state name. I'm going to add test 1, 2, 3, and is completed false. False. Finish up here, and then the reducer. What do I need to do? Just call it to-do reducer. That's it. But we have another problem here on the content view, which is when you start the project, the app is calling the content view, and this is failing, right? Because it's not adding the store. So let's just place this here and get the preview going. Yeah, it's taking a bit. Previews are not the most reliable. You can see here. So I mark it and unmark it, and that's it. I believe we're running a little bit out of time, but I want to show you guys how would I handle it, the handling of several components in the to-do list. So I already have here the code, the full code that you saw in the demo. So I'm going to show you guys. This will be made available, and there is a more complex version of this demo in the point-free GitHub, so you guys can go and check. So basically, after the to-do view, I would need to add the to-dos, the list. So basically here, I would need to create a reducer again, like you guys said, and I would need to have the identified array of to-do state. And I'm going to say that in TCA, you usually don't see just array. It's best for you to use identified array of, because with IDs, it's very easy to use to check elements. And this is a good practice of TCA. So you'll see in a lot of demonstrations, they don't use arrays. But if you use identified array, you need in the to-do view to have an ID. this needs to have to be of type identifiable, so you need to create an ID. In our case, we didn't need it, right? So we didn't have it, but when we would reach this part, we would need to add an ID. But in the case of the list, we would have a lot of actions. So in this case, what actions do you guys see here? The add to-dos, right? This button here, the clear, and the delete. So let's see it. The add, the delete, and the clear. And we need to have the binding. So Kushal, are you seeing the gluing part of the TCA? So the parent, the to-dos, needs to conform to bindable action as well. So it needs to bind it to the state. So in the body, like I told you guys, you need to call binding reducer first to bind the children, the child views, and then in the reduce, you still need to have the case for binding because it will launch an error if you don't have it. But in the actions in this case, basically, for example, for the add to do button tapped, what would you do? You just need to change the state, right? So you would add an insert with a new UUID at 0. That's it, because I want it to appear first, due to the to-dos being best to be seen first, but you could add at the bottom. And the delete, you would just remove at that ID. This is easier to do than you would remove this ID. And then the clear would be a filter, because as a parent, I can see for my children, I can check all of them, all of the states of them, and see which of them are completed. This is the advantage of binding, right? So I can have all of the state of the to-dos and check if some are completed or not. So this is the main actions, and you would need to have, since you have the actions for the to-do, you would need to have to call the to-do reducer for every element that you have on the list. But on the UI side, so as you can see here, I also didn't call the view store. I just have a binding. And for the list, I would need to call this for each and would need to scope the state. This scoping is needed because when you scope a store, you create another store. But since it's a child store, you don't want to create a store that has all of this stuff, right? The to-do doesn't need all of that. So you need to scope the store. And what do you need to scope it with? The state of the to-dos and an action for to-dos and call it. That's it. So for each bar item, or for example, the delete action on delete, right? For each element, I would send through the store the action that we called before. So I would call them here, store.send, add button tapped, and so forth. And this would be enough to create the demo that you guys saw. Unfortunately, I know that we don't have a lot of time, but I want to move forward as well. I don't have a lot of slides left, but this is basically the challenge. And you can check on my GitHub for the full project. So what you guys saw here, you can check it on GitHub as well. So if you guys want to take a picture, be my guest, you can check it on my GitHub and on Point3's GitHub as well in a more complex version. So let's wrap everything up and take what Kushal said, like, why don't I need them? Shouldn't I use MVC and MVP and model view presenter? And let's talk first the main advantages. So the main advantages of TCA, it is more readable once you understand it, because I think some of you guys maybe it's not more readable, and that's okay. But once you understand how the structure is created, it's very easy to add and remove everything. It's very easy to implement tests. You just need to send and receive actions through the store. You can create very small components, and maybe you don't need to add TCA, but components are integrated very easily. And components can be isolated, as you saw there. The to-do element can be isolated and shared in another screen that would need it. But the disadvantages, and Satya, sorry, do you want to add anything? Sorry, I thought your mic was on. Never mind. So the main disadvantages of of TCA. This is not a solution for everything. This is very powerful and very cool to use, very fast, but it's 1 hour and a half. It's not enough to learn everything there is. And it is a third-party library, guys. So every time you add a dependency to your project is another problem that you may have down the line when there is a breaking change and you need to change it, but you still have to implement features. So you may not need a third-party dependency. For example, MVC, it's not a third-party dependency, right? It's an architectural design pattern. So you don't need to install anything. And it has a very complex logic for a small-scale project. Of course, this to-do list doesn't need to be MVC. It doesn't need to be TCA, right? It could be a simple MVC. So, and also you need to add many packages, like you can see here. And every time you build, this will slow your project down. So just be on the lookout that this is not a one size fits all. You don't need to use TCA from now on. It's just a tool in your tool belt. So do you guys have any questions?
Is there any native framework, Apple framework to manage state instead of using a third party?
Yeah, Apple and especially SwiftUI already has a lot of these components, and TCA is not creating something new, Kushal. Very great question. If you see most of the descriptions of the new updates, they mostly just take what Apple has and add stuff to it that makes sense to TCA. So yeah, if you search, for example, this part, these are managing state. See, this is Swift. This is not a third party. They already have this logic here. So you can use just the Swift logic and be good with it, you know?
Okay.
But thank you so much. Great question. No problem, Venus. In your opinion, when should we use TCA? So I'm going to talk to you guys about a situation that happened in my company that I think TCA was very very beneficial. For example, we had a tutorial screen that had a list of tutorials and a lot of screens, but the complexity would be very overwhelming to implement if we used MVC. And there were a lot of interactions in this tutorial, a lot of videos being played, not videos, but animations. And for example, if I clicked on another screen, the animation would stop. And this was very, very beneficial for us to implement in TCA because it was very easy for me to create a component called timer, for example. And the timer just receives a stop and start. This in MVC, for example, would be very different, very difficult to implement. So in this case, when you have a large feature and you have a lot of components that can be isolated and can be implemented throughout a lot of screens, maybe it's a good idea to implement TCA. But maybe it's not. It depends on your way of thinking, on your company's way of implementing everything. So it really depends, Venus, but this is just an example. And thank you so much for asking. Does anyone have any more questions? Don't be afraid, guys. You guys can ask away. Okay, I'm going to move forward now, but thank you so much for the questions asked. And thank you so much to Mobile First Applications Fin Integration for hosting this event on Meetup. I'm very happy to be a part of this and hopefully got you started on TCA and you learned something new today. And thank you so much to Arjun Gautami for the invitation. This was a first. I didn't know, I wasn't sure if this would go well but I'm very excited. And Ratnesh, go ahead. Sorry.
Sorry for interruption. Like I had a question. Like, are
Yeah,
you guys
sure.
using the modularization using local Swift packages or just
Yes.
okay, so in that case, how do you test all the test cases
It's 2:30.
in one run? When using Swift Package Manager, like they provide test target for each isolated feature. So how do you run a command line tool or like in Xcode run all the tests at once?
Yeah, I'm not. I can show you, of course, the base code, but I can tell you this: we have modularization, and basically we have a very large package Swift that handles all of the package interactions, and everything is declared there. So, for example, we have here. I didn't have a package Swift, right? I only had one dependency, but imagine the modularization. I would have a package Swift, and then I can go to each model in the schemas. And of course that, for example, when I'm building for the app, I don't want to constantly building for example, the app that I'm building. I'm most of the time I'm on just a smaller component. And of course, Ratnesh, if I'm going to, for example, Bloom a module and I'm building that, it takes a lot of time, a lot. So in terms of performance, it's not the best, of course. It's improving, but it's a necessary evil, if I would say, than just having everything in the same project, in the same module. Would that answer your question?
Actually, I'm asking about the running the unit test all at once when in the Swift packages.
Oh yeah. So I think there is just not one problem. For example, if I have a module, right, and I have tests for that module, I would just go here, click on the module, and go to the test and run it. I wouldn't have any trouble.
Yeah, right.
But
it's fine for the single features, but for the all main features like integration test that we write for the whole modules, like the single parent feature. Okay,
oh
so,
yeah.
So in the CI/CD pipeline, we don't we cannot switch each individual test scheme, right?
Yeah.
So how do you solve that thing? Like
Great question. Then I would need to see the package Swift, how it all handles it. But we have CI/CD. So we are running all of the tests, of course, and for each, I would need to have the target to run those tests. And I would need to run package by package and but the question is, how do I declare this? Or how do I do it, right?
yes.
This is a very complex question, Ratnesh, and I don't have the answer for you. I will need to see, to check, but I can reply to you after this meeting. How does that sound?
Sure. Thanks.
Thank you so much for asking. Thank you. Great question. And going back a little bit again, thank you to Arjun Gautami again for the invitation. And thank you guys so much for coming today. And if you guys want to follow me, you can take a picture of my link tree. There's all of you guys can connect with me on Twitter or X, sorry guys, the LinkedIn, GitHub, and all of that. And thank you so much for coming today and spending a little bit of your day with me and learning about TCA. So thank you guys so much.
So
Thank
at
you.
before the wrap up this meeting, I'm really thankful for the Vera, you are sharing the insightful knowledge with us. So it's really great and useful in our real-time use case in the daily programming. So that's thank you so much for all the things you are sharing and your spend.
Awesome. Thank you so much. Thank you so much, Arjun.
Yeah. And we are thankful to Mobile First, so we to provide our provide a platform to share the knowledge and organize the event like this. Yeah.
Thank you.
And also we can plan for next month another session, and we have a WhatsApp group, so you guys can, I just shared that detail, so everyone can join and you just a second, I can share that. Just a second, I'll get that.
Yeah, no problem.
So we have a WhatsApp group, so everyone can join. So we will update everything on that our channel, so everyone can
Awesome.
update with. Also, we will share the Git link. This where I will share with us, and also we
Yeah.
will share it on that. So